Later in the Devlab series, we will come back to the Debian router we created in the previous episode to configure DHCP and other services. In this episode, we will deploy a virtual router based on RouterOS and configure DHCP automations as we discussed in the previous episode. RouterOS is a commercial product sold by MikroTik. Although it is neither free nor open source, I think it is a stable virtual router and I use it to test the configurations I want to push to my physical MikroTik router that protects the edge of my network. I have tried a few other virtual routers and I might go back to some of them later. But currently I prefer RouterOS because of two main reasons. First, it requires less attention than any other virtual router I have tried, and it is very easy to automate using the community.routerOS Ansible collection. The main disadvantage of RouterOS is that it is totally locked down. We have no idea how stuff works, and when we SSH to the router, we land on a custom shell that only allows API commands. This is good enough for a home lab and perfect for a production environment. But for my Devlab, I would love to understand what the router does under the hood, which is what I can do with my Linux router. Some people might say that RouterOS is expensive, and I do not agree. I think the pricing is reasonable, especially when compared with enterprise competitors. You can use the virtual router for free without a license, but you are limited to 1 megabit per second connections, which is too slow for anything other than testing the configuration. MikroTik offers a 60-day trial license, and it is easy to automate getting a trial license, which is what we will do. Our plan for this episode is to improve our Proxmox automation tools and to deploy and configure RouterOS in a repeatable way, so that we can reconfigure the router if needed using infrastructure as code concepts, or delete it completely and recreate it from scratch. First, we will create an Ansible role to build a virtual machine template. Then we will use that role in a playbook to create a template for RouterOS Cloud Router. Then we will create a role to clone the template and use it in a playbook to deploy a virtual router to our Devlab. We will also create a role to configure the router and use it to configure the virtual router to serve our DHCP automations that we discussed in the previous episode. This is a generic role for creating a Proxmox virtual machine template. First, we create the VM, and when we create the VM, we have the normal connection variables. Then we specify the name of the template, the VM ID of the template, how much memory we give it, and I prefer to use QXL so that I can get the SPICE connection for the terminal. We create the network interfaces if we have any interfaces passed. For that, we use the Proxmox_NIC model in the community.general collection. Here we pass the normal variables. We don't need to specify the node because we already know the VM ID. We specify the interface and the bridge and the firewall versions. Since we are creating a template, we will be able to override any other settings later on when we clone the template. And we call this model for as many times as we have in the interfaces. So interfaces should be an array, and we loop through this array and create all the interfaces needed for virtual machine template. Then we attach a disk image, and here we need to specify also the VM ID. Where do we want to put the disk and the storage, the format. I'm always using SSD, so I add the SSD options, but the most important thing is import from. For this, we will need a disk image, and I will show you how to get the disk image for RouterOS. Normally, the disk images are distributed in a compressed form, so they might require resizing. So here we resize the disk image using the Proxmox disk model in the community.general collection. We modify the boot sequence to boot from the new disk that we created, we attached to the virtual machine later. Since the machine can now boot from that disk, we convert it to template. For this to work, we need to have a few variables. So the variables we define for RouterOS are the version, and we will use that version later on in the playbook when we get the template. We have the VM ID, the name of the template, the RAM of the template. If we are resizing the disk, we specify how much we resize it. Where do we store it? These are the interfaces, the network interfaces. One of them is connected to VMBR0. The other one is connected to VMBR100. And then where we want to mount the disk. We get the disk image from Microtech's website. So this is Microtech's website, and I clicked on software and I browse it under the cloud hosted router. What I care about is the raw disk image, which works well with Proxmox. The URL for the disk image follows a repeatable pattern that depends on the version. We can put that pattern in a task in a playbook. This is the pattern. We have the URL, then the version, and then chr dash the version, then the extension, and it is copied with it's compressed with the zip format. This task runs on the Devlab. We have to run it on the Devlab because in order to attach a disk image into a virtual machine, the disk image must be on the Proxmox virtual environment. So this is the Proxmox virtual environment. And to reach it, we have two conditions. We have first, we need to define it in our inventory. So in our inventory, we add the Devlab to the inventory, and this is its IP. The second thing is we need to be able to connect to that host. We need to connect from our Ansible controller here to the Proxmox that runs the Ansible controller. To do that, we can use the SSH copy ID command with the user and the IP on the remote host. Normally it asks us for the password. We supply the password. We get a result that the number of key added is 1. If we connect again to that host, we see that we can connect without a password. So we are ready to connect, and if we look at the tasks in this playbook again, we see also that we attach the RouterOS variables file that we created, we have seen. And we see also that we might need to install Unzip, because this runs on Proxmox, and Proxmox does not include Unzip, the Unzip utility by default. So we need to install it so that we can unzip the image. We download the image using the Ansible.builtin.unarchive module. This module accepts a remote source. And by remote source, it means that the module can download a file from the internet and extract it. And we put the extracted file in under the temp directory. Now we can create the RouterOS template using the role that we have seen, also with the variables. We convert these variables from the RouterOS format to the role format here, and then first we purge the template using the purge role that we created in the second episode of the series, and then we create the VM template. We run the playbook using the inventory file. This is the playbook and this is the inventory file. We run the playbook and we see what happens. Get the image. The image was downloaded. It was already there. Then the disk image was resized and it was configured to boot from the disk, and that the VM was converted into a template. And we see here that we have a template ready. If we look at the options, we see that boot order includes our drive, and in the hardware we see that we have the drive, and we have the network interfaces correctly set, one to VMBR0 and the other one to VMBR100. So now we are ready to create an instance of this template. This is the role for cloning a VM template into a VM. We use the Proxmox KVM model with the clone with the clone variable with the template name, and we give it a virtual machine ID and a name of the template, and we specify where we want to put the storage and whether it is a full clone or a linked clone. Then in our cases, we need to update the interfaces. So we need to pass the interfaces with the new MAC addresses that we want to use for this VM so that it gets IPs automatically. Then we start the VM, which is the normal starting, and we wait for the VM to start. I noticed that some VMs might take up to 15 seconds to start, and this happened with the RouterOS version as well. This role requires a few variables: VM ID and the VM name and the network interfaces and the template name, which is what we defined earlier. And here, when we define it, we use 225 as the template ID, as the VM ID, which matches our setup for this Proxmox virtual environment that simulates my actual main Devlab. Then we need to take care of the MAC addresses so that we get the IP addresses we need according to our DHCP automation scheme. The first MAC address would start with 02 because it is on VMBR0, and that is the rule for VMBR0. And the second MAC address would start with 12 because it is on VMBR100, and that is the rule for VMBR100. And we need to give this machine the IP 225, so we give it a MAC address that ends with 0225 on the main network on VMBR0. And here we can decide we will have the IP static. Here is a small playbook that would recreate the VM. And here we see we pass only the required variables, and we call the the BVE purge role that we have seen before, we have used in multiple times before. And then we call the new clone role that we have just created. So let's see what happens when we call this role. So we don't need the inventory file, and if I run it, so now we should have a working router, and you see we have a MikroTik working router. Logging into the router, we use the default username and password, which are admin and no password. And at first login, MikroTik offers to show me the license. I will pass that. Then I have to change the password. I will give it a temporary password because we will recreate this router later. And here I can check the configuration. The way MikroTik works is that you have commands. For example, IB. If I press IB and I press tab twice, I get all the options that I can use under IB. So here I want to check the IB address. If I press tab again, I get all the commands that I can use for IB addresses. I can add or disable or delete or print IB addresses. So if I print the IB address, I see that I got an IB, the IB 225 from the actual main router, which is what I am expecting since I used the MAC address that ends with 0225. Since I have an IB, I can check the web interface for the router. And here I can log in with the password I just created, and I see that I have two interfaces. One of them is currently operational, which is the interface that I am using to access the router. And under IB, I can see the DHCP client, and I see that I have acquired an IB from the DHCP server on the main router. And then under DHCP server, I don't see anything here. So what we need to do now is to configure routing between the two interfaces that we have on this router, and to configure DHCP client to serve the DHCP automation scheme we designed in the previous episode. Here is the Ansible collection for RouterOS, community.routerOS. This collection allows us to use the following model. We have the API model that we will use extensively today. API facts model. We will also use the API info model and the API modify model. I think we will use the command model as well. And we will use all these in a custom role that I created called RouterOS. So if we look at the RouterOS role, we see that first we go to the we log into the router using the username admin and without password, and we call the user path and we create a new user. So we use the add command and we add a new user with full access and it's not disabled. Then we disable the admin user. So we use the API modify to disable the admin user. Now, then we can get a trial license. So the command for getting a trial license, we use the API model with the path system license, and the command would be renew, and we give it our MikroTik account. And to use that, you need to have a MikroTik account and to have your MikroTik username and password added to your Vault. So in the Vault template now, I have MikroTik username and the MikroTik password. And I also added the Devlab username and password as well. So we get a trial license and we get that when we need it. I don't want to get a new license when every time I deploy the router. So when I am testing, I don't need a new license. So we need to pass a variable new license, which has a default value of false. Then we start by getting bridge information. We get all the bridge port information and we delete all the bridge ports because we want to recreate it. So if there are any configurations, if I was playing, if there are default configurations, I want to get rid of them all. Then I get rid of the bridges, API info, then API info, then API. Here we removed the bridge, and then here we add a new bridge with the bridge name that we will pass from our variables, and we will see the variables later. Then we add the default bridge ports, also following the same command, and we loop through all the interfaces, all the LAN interfaces that we have from the variables file. We create a bridge and we add all our LAN interfaces to that bridge. And then we assign the IP address to the bridge. We using the IP prefix that we provide and the bridge name. So this will create a new IP address on that bridge. Then we get all the DHCP network information. We delete the network if it exists. If there is any network, we delete it. We loop through all the networks. And we also delete all the pools that we have defined. So we get the pool info and we delete all the pools. And then we get all the servers and we delete all the servers that are running on this instance. Then we start creating DHCP. So first we create the DHCP network, then we create the pool, then we create the DHCP server, also passing the variable that we will see in a bit. Then we need to configure routing as we did in the Debian router. So we need to configure NAT to allow post routing. So first we delete all the NAT rules. Then we add a new NAT rule with out interface, our one interface, and we ask it to masquerade, which is basically the same rule we did in our Debian router. Now we need to configure DHCP leases, and we get all the lease information. We remove everything. We remove all the leases. You need to be careful when you run this role, because if you have existing leases, existing things that have IPs on the network, you need to be careful with that, because these IPs might be reassigned again when you run the role and you have non-static IPs. We add the default DHCP leases. Also, we use a range reservation start, reservation end +1, and we convert that to a list. And if you see, you see here we use the MAC address, the MAC prefix, then the item, the number that we get from here, which is by default an integer, we divide it by 100 and we take the result of the division. Then we add the remainder of the division. And for this IB, we assign it the IB prefix, not the item, which is the IB itself. And we will run the roll in a bit and see what happens. Then if we have static leases, we add the static leases. And here we do not have to do any magic, because we expect to get the prefix and the IB from the configuration, from the variables. So basically what we did is we cleaned up the configuration that we want to recreate, and we recreated them according to our needs. That include clearing up any default configuration that RouterOS might have in case they change their configuration in the future. We have seen the variables up till here. Now we need to give it to define the host name, which is the IB that we get for the router. We give it the bridge name. The bridge name would be the Devlab here, and the LAN interfaces would be Ether2. The WAN interfaces would be Ether1. If you want to create multiple interfaces, you can add them here. The IB prefix would be .100, and the MAC prefix would be the 12 MAC prefix. The default DNS resolver would be the network's DNS resolver, and you can add DNS resolution on the router. It can relay DNS queries, and it can also save a few DNS hosts in its cache if you want to do that. But for that, we will use a proper DNS server later in the series. We will use bind9 DNS server. The pool name, and the pool starts from IB20 to 50 using the prefix that we have. Then the reservations for our Proxmox gets start from 100, they end at 154. The DHCP server name would be Devlab, and these are the static leases that we have. So we have the 99, which is the Proxmox virtual environment that we have. And we have the 90, the IB90, which is the machine that we have already deployed, the Debian machine that we have already deployed, and we checked the previous time. So now let's run this role and see what happens. Here is a playbook that would run the role, and we see that in this playbook, we change the variables to use the variables in the roles, and we call PVE purge, then PVE VM clone, and then the RouterOS role that we created now. And if I run this role runs on localhost, so I don't need an inventory. Ansible playbook, and I give it RouterOS, the router, and let's see what happens. And we are adding the DHCP pool now. I cut it to 154 so that it does not take a long time when we are running. I will change the variable to 254 when I deploy this later. So and we have added also our static leases, and it was all successful. Looking at the router, we can now log in with the new Devlab user. And here we see under IB, for example, that in the DHCP server, we have a Devlab DHCP, and leases, we have the few leases defined. And we can check that by going to the desktop here. So I configured this desktop to use dynamic DHCP to be configured via DHCP. So now If I connect from this desktop, I see that I already got an IP address. And if I look here, I see that I have a lease that was assigned to the static IP that I am expecting, to the 90. And I see that this host has a lease. And if I open Firefox here, and if I go to a host, for example, Ansible.com, I got a response, but it is very slow because it's working on 1 megabit per second, which is very slow. To solve that, we need to redeploy the router with a license. So let's get a license. Let's first start by increasing the host reservations until the official end that we want. Then we clear, and then we call the RouterOS role with the renew underscore license equals true. And this should get us a license from MikroTik. You see, we got a new trial license. And we can confirm that on the router itself by logging in as Devlab again. So we have all the reservations until 254, but that reservation for the machine that was running has been released. Luckily, this machine uses a static IP, so if I disconnect and connect again, I get the same IP, I get the same reservations. If it was from the pool and there are other clients on the pool, that would create a problem, so you need to be careful when you run these roles. And if I refresh the page now, I get a lot faster connection. Maybe this was the cache, but normally the license works and I got a faster connection. All the code that I have written here will be committed to a Git repository that will be shared on GitHub or GitLab. I'm still not decided yet, but I will do that after I install GitLab in my Devlab in this series. You will see the code link in all the previous episodes and in the next episodes. Also, I will be doing some write-ups for explaining the logic and the comments that I have used in this series, and the links to these articles all will be linked in the description below. The articles also will include all the links that I am showing during the presentation. In the next episode, we will build the Devlab BVE, which is what we have been using so far. Then we will be installing GitLab and pushing the code and publishing it. Then we will build GitLab runners so that if we change something in the code, for example, we have automations that will deploy these changes automatically using infrastructure as code concepts. We will also experiment with Jenkins automations and deploy Jenkins with Ansible, and also deploy Jenkins runners so that we can also use Jenkins automations if we need to. I have plans to install Kia and WireGuard on the Debian router, as I said multiple times, and I also have plans to create development environments for many of the most leading software projects to help people who want to contribute to open source. Please subscribe so that you can follow up the Devlab series, and see you on the next episode.